is all of your notes and your practice for the rest of the year. So if you look in order, you'll see that this is 10.1 note taker, and then there's 10.1 practice.
We just got to turn this whole thing in.
Then there's 10.2 note taker still, and then practice. So there's practice and notes for sections 1, 2, 4, 6, and 8. So we're skipping sections 3, 5, and 7 because we don't have enough time. So I picked the most important lessons that you need to learn before going on to geometry. So you're not necessarily going to turn this packet in, but say if I give you homework tonight, then tomorrow you'll just come show me your homework. So I'm not going to take it up, but I might check it daily. So tomorrow, if I say show me 10.1 practice, then this is what you'll show me. Okay? I also have page numbers on them. So if I say turn to page number so-and-so, you'll know which page to turn to. So right now, you should all be off your phones. You should have your name in here in pen. And then I'm going to say that this is my 4th period packet.
Why didn't you put your first name?
Because I go by last name here. Okay? Alright, so 10.1 is really not bad. It's just a lot of vocabulary. So everybody should be looking up here because this is our notes. So look up here. Shh. Chapter 10 is all on circles. So like some of the chapters were all on parallelograms and rectangles and triangles. This whole chapter is on circles and the different parts of circles. So I want you to read one paragraph or one sentence at a time if I ask you to read. So Skylar, will you read the first sentence for me?
A segment with endpoints that are all at the center.
Right here.
A circle consists of all points in a plane that are a given distance called the radius from a given point called the center.
Okay, so this point in the middle, point F, is our center. That's the center of our circle. Everything else that is coming from F to the ends, that's called your radius. A segment or a line can intersect in several different ways. The first one, a segment with endpoints that are at the center and on the circle. So if it has an endpoint on the center and the circle, that is called a radius. So underline it, highlight it, circle it. If there's an endpoint at the center and on the circle, that's a radius. So for example, a radius is 1, radii is more than 1. So there are more than one radius here. There's actually 3. Our radii are DF. And the same applies. You don't have to put it in a certain order. FD is also a radius. So we have DF, FB, and FC. Those are all radii in this circle. A segment with endpoints on the circle is called a chord. So a chord has to have both endpoints on the circle. For example, AE. AE is a chord because both A and E are on the circle. What's another chord? DB. DB is also called a diameter. So a diameter can also be a chord. So DB is a chord and a diameter. We just talked about a diameter. It is a chord that passes through the center. You know that the diameter is 2 times the radius, right? So a diameter is the whole thing, radius is half. So in these examples right here, we name a circle by putting a circle and then a dot in the middle of it. So that stands for circle. So the name of this circle right here is dot with a circle with a dot in the middle. Circle O is the name of this circle. So you reference it by talking about the center. The center is O. So if we were naming this circle, it would be circle O. Okay, I want you to write down the radii of this circle. There are 4. So write down all the different radii. Write one here, here, and here. Alright. Are you done writing the radii? Yeah, tell me what you got, Heaven.
Is A2
AQ, oh, AO. That's O.
Oh, my bad.
Yeah, you're right. So AO is 1. Jarek, what's another one? OB. Anne-Marie, what's another one?
CO. OC.
CO or OC. Emma, what's the last one? OD. Those are the radii. Okay, next I want you to name the chords. A chord touches both ends of a circle. There are only 2 of them. So name the 2 chords.
AB.
Thank you, AJ. Let's not call them out anymore. AB. And what else, Skylar?
CD.
CD. Very good. Okay, I want you to finish 1 through 7 in your group.
Miss Deacon,
Yes?
so, like, the 2 diameters, they're the same, right?
Right.
And then the AX and YB are the same because the 2 diameters are the same, right?
Yes.
Okay.
Circle R. So remember to name it. You put a circle with a dot. So circle R. Ginny, name the radii of the circle. RX is 1. Name another one. R what? RB. RA and RY. Good. Alright, Francisco, name chords. AX, YB. There's 2 more. Yep, good. AB and YX. Remember, a diameter is still a chord. A chord is a diameter, okay? A diameter is a chord. All right, so name the diameters of the circle. Jarek, what'd you put for the diameters? AB and what? Very good. AB and YX. They go through the direct center of this circle. Okay, 5. If AB, which is the diameter, if AB is 18, what is half of that? What's the radius, D? 9. Good, 9 millimeters. Malachi, if RY, this one right here, is 10, what is AR? 10. And what's AB? 20. Very good. Because AB is just another radius. So if one radius is 10, then all of the radii are 10. And then all the diameters, which is AB, would be 20 inches. Is AB congruent to XY? What do y'all think? Are the diameters congruent? Absolutely. And all the radius congruent? Yes. Yes.
You just said AB's 10 and AB's 20.
Did I write that backwards? I meant AR right here. I don't know, so you haven't even made the test, okay? Let's just put all this knowledge into our brain, and if it's on the test, then you'll know it. That's all right. All right, let's go to the next page. On the back, we're talking about circumference. Circumference. So I have this rubber band right here. And if I were to find the circumference, this is how, like if you take a globe, okay? If you take a globe, guys, I want you to stay with me, please. If you take a globe or something round and you want to find their circumference, it's like taking a measuring like, or some kind of measuring, what are those things called? Tape measure or something. And you take it from one point of the globe and you wrap it all the way around the globe. That's finding the circumference. It's the very middle, all the way around. That's called their circumference. And there's two ways to find their circumference. You can either use the diameter, C equals pi d. So to find the circumference using the diameter, you just multiply it by pi. Or if you have the radius, you use C equals 2 pi r. So there's two different options, depending on if you have the radius or the diameter. So in this example right here, find the circumference of the circle to the nearest hundredth. Well, do I have the radius or the diameter? Radius. So I'm using C equals 2 pi r when your radius is 13. So if you simplify that, 2 times 13 is 26. So in order to find the circumference, you would plug in your calculator 26 times pi, which is 81.68. So their circumference is either 26 pi or about 81.7 centimeters. Okay, so for number 1, find the diameter and the radius of a circle if we're given the circumference. Well, if I know the circumference is 40, are y'all paying attention? If I know the circumference is 40 and I want to find the diameter, can't I just divide it by pi? I would do that if I were you. I would every time I'd find the diameter first. Because in this case, I have to find the diameter and the radius. So if I know to divide 40 by pi, my diameter becomes, round to the nearest hundredth, my diameter is 12.73, right? Well, if I know that the diameter is 12.73, how do I find a radius? Half it. So divide it by 2. And your radius is 6.37. Okay, so for 3 and 5, I want you to find the diameter and then the radius. Diameter and the radius. Don't worry about 2, 4, 6. Find the diameter and radius of 3 and 5. Round it to the nearest hundredth. Hey, y'all aren't going ahead to the bottom of the bar, y'all. No. So divide the circumference by pi, and you'll get the diameter. Once you have the diameter, divide that by 2, and you'll get the radius.
Wait. Okay, Miss Courtney.
I said round it to the nearest hundred. So we're just leave it as 4.97.
I just rounded it.
Justice, are you done?
Wait, once we get this out, do diameter by what?
Divide the diameter by 2 to get the radius.
2.49.
You wouldn't do 2, 4, and 6.
If you want to, you can, but I wasn't gonna make it. Wait, David, don't go ahead. There's one part that I need to explain. Don't go ahead. All right. So, AJ, what did you get for 3 for the diameter?
4.97.
4.97?
Yeah.
Does everybody agree?
For 3?
For 3, yeah.
Yes.
Okay. When we divide that by 2, what did y'all get? What's the radius for 3? Say it. 2.48? Do y'all agree? So what y'all got? 49. Okay, we might have had a rounding error. Okay. Irving, what did you get for the diameter of 5? 2 point what? 5.3. And then Nicole, the radius? Ooh, what happened?
Yeah, I forgot what to say. Hold up.
79. 79.5 divided by pi.
I got 12.6.
Oh, did you say 25.3?
Yes, 25.31.
Okay, that makes sense. Now, Nicole, you said 12 point what? Okay. You see how you can notice if something's not right? Because I knew the radius had to be half of the diameter. And if the diameter was 2.5, then I knew something wasn't right. All right. So now we're actually going to use circles. So we have to find, the one reason I did not want y'all to move on is because there's a difference in exact circumference. Okay, there's a difference between circumference.
What is the diameter?
Is 25.1 or 0.3, 25.3. The exact circumference means we do not want to round. Okay, so if I'm using circumference equals pi d, I need to find the diameter to find the circumference. Well, in number 7, I need to use what? Pythagorean theorem. I know that this is A or B, but I'm solving for C. So 8 squared plus 6 squared is square root of 100, or is 100, and when I take the square root of 100, my diameter is 10. So here's what I mean by exact circumference, and it's actually a little bit easier. When I plug in the diameter, my exact circumference is 10 pi, or pi times 10. That's what I mean by exact. Because if I plug 10 times pi into my calculator, I'm going to get a long decimal, and I don't want to round. So my answer for number 7 is just 10 pi. Right. Well, look at number 8.
12.73.
If this is 9, hey, but remember, I don't want any decimals. If this is 9 and this is 9, that means it has to be a 45, 45, 90 triangle, right? And in a 45, 45, 90 triangle, if this is 90, 45, and 45, if this is x and this is x, then this is x square root of 2. So in this case, I know that this is 45, 45, and 90. And this side's 90 and this side's 90. So my hypotenuse is 9 square root of 2. Since the diameter is 9 square root of 2, plug it in your formula, and we know that the circumference is 9 square root of 2 times pi.
I got the same thing.
Okay, but I don't want a decimal. That's the exact circumference. 9 square root of 2 times pi. Justice, are you with us? What about 10? If this side is 11, that means this side is also 11. So if I want to find this, huh?
Diameter is 11.
Yeah, the diameter is 11.
No. Yeah, the diameter is 11.
Yeah.
You're right.
It's shown.
Because you could use this one right here. So your circumference is just, your diameter is 11, so your circumference is 11 pi. AJ, wake him up. 12. This is another 90, 45, 45. So if I'm finding the diameter, and this is the square root of 2, Jarek, square root of 2 to find the hypotenuse, or the diameter, I have to do square root of 2 times what? Square root of 2, which is the square root of 4, which simplifies to be, what's the square root of 4? 2. So your circumference is 2 pi. So I want y'all to try 9 and 11. Here's the thing about 9.
Wouldn't it be like
If that's 3, so is this. So use Pythagorean theorem to find the diameter.
Hey, go to 8.
Please.
Please.
Okay, I want you to try 9 and 11. You have to use Pythagorean theorem for 9 and 11.